All right, so let's do a few application problems. All right, so here in these first couple ones, we're just being asked to just write the applications. We don't have to solve the problem, so we're just being asked to write the function. Okay, so a rectangular box has a square base. So it's kind of like a little box like that, okay, and then the base is a square. So if the sides are x, then the dimensions of that are just x times x. All right, and then it also says, oh, we're supposed to use w. All right, we can do that. All right, so this is w, and then it's saying the height is half of the width, so 1/2. Okay, and then find a function that models the volume. Well, volume of a rectangular prism or a box is the length times the width times the height. So our volume in terms of that side w would be, let's see, we do all w's multiplied together. So it would end up being, 1/3. Not 1/3, 1/2. W times w times w. All right, let's look at this next one. The height of a cylinder is 5 times its radius. Okay, so if we had some radius here, then its height is 5r. And then the volume really for anything is the length times the width times the height. Okay, so you basically find the area of the base, and in this case of a cylinder, the base is a circle, so pi r squared would be the area of the base, and then we multiply that times the height. So volume in terms of the radius would be pi r squared, and then height is 5 times r. So that gives us our function of 5 pi times r cubed. Okay, let's try another one. A rectangle has a perimeter of 20 feet. Find a function that models its area in terms of a side length x. Okay, so we have a rectangle. Okay, let's call the length x. Okay, so we had 20 feet to work with to go all the way around this rectangle. Okay, so the perimeter would be 2 times the length plus 2 times the width. Well, we don't know what the width is, but we know the perimeter is 20, and we just said that x is going to be our length. So let's come up with an expression for width. I'm going to divide everything by 2. So I have 10 equals x plus width, and then that could tell us an expression for width, if we subtracted x from both sides, would be 10 minus x. So that's going to be what we give for our width. And now we need to find a function that models its area. All right, well, area is length times width. So we would have x times 10 minus x. So it would be 10x minus x squared. All right, so that's good kind of warm up for us. Now we're going to actually solve some problems. Okay, so let's say that we have a example where we're going to work with similar triangles. So we have a man walking away from a lamppost, and the light source is 5 meters above the ground. So this is 5 right here. The man is 2 meters tall. And how long is the man's shadow? When he is 12 meters from the lamppost. So we're trying to find the length of his shadow. Okay, so with similar triangles, we want to compare the same thing. So I'm going to do height compared to base, and I'm going to do that for the lamppost. So it would be 5, and then the base would be this whole length, which would be 12 plus x. So we're going to go height to base of lamppost is equal to height to base of the man. And then we can solve that. We'll set cross products equal. So we have 5 times x is equal to 2 times 12 plus x. And then that would give us 5x is equal to 24 plus 2x. And subtracting 2x from both sides, we get 3x equals 24, so x equals 8. And then we just write a sentence showing what that means in the context of this problem. So the man shadow is 5 meters long. All right, let's do another one where we're going to be looking at maximizing profits here. So let's say that we have a manufacturer finds that the revenue generated by selling a certain number of packages of lilikoi butter mochi is given by this function. R of x equals 60x minus 0.5x squared, okay, where that's the revenue and that's being measured in dollars. So we want to know what the maximum revenue we can make is, and then how many actual packages of the lilikoi butter mochi we need to make. So when we're being asked to maximize something and we have a quadratic, what we're being asked to do is find the vertex. Okay, so let me just put this in kind of order. So I'm going to write it in descending order with the negative 0.5x squared first and then plus 60x. And then just looking at our coefficients, the coefficient of x squared is negative 0.5, so that's our A. Our B is the coefficient of x, and then our constant, there's no number, so C would be 0, but we don't need that for our vertex. So the vertex is given by this formula, x equals negative b over 2a. So we're going to plug in negative b, so negative 60 over 2 times negative 0.5. So that gives us that x is 60. Okay, so we need to make 60 packages of butter mochi. And I only have one lilikoi in my kitchen, so I don't think this is going to work for me. But, okay, now to find y, what you're going to do is you're just going to plug that right in to your equation, the x that you just found, okay? And then that'll give us the maximum profit, so the maximum amount of money we can make here. Okay, so 60 times x minus 0.5 times x squared, so times 60 squared. And that gives us, let's see, that gives us 1,800. So to maximize profit, make 60 packages and you can expect a maximum revenue of $1,800. Okay, so let me show you how to do this on both the TI-80 84, let's see what I have. Oh, okay, and Desmos. All right. So even if I'm using a graphing calculator or Desmos, I'm still going to find that vertex because it really helps me figure out how to graph what my window should be. Desmos is kind of nice because it's a little easier to find the graph and that maximum value. So on Desmos, all you have to do is just type this in, y equals 60x minus 0.5x squared. Okay, right, but it's all kind of weirdly messed up, and so you can kind of scoot around and zoom in and out, but it's kind of hard to find it. Okay, if you found the vertex, that's extremely helpful because I know that it needs to go to 60, so I'm going to do like -1. The only reason I do that is because I like to see that axis. Okay, but I know that I'm going to maximize profit when x equals 60, so let's go beyond that, like to 100. Okay, and then my output, that's my Y, was at 1,800. So if we go to past that to like 2,000, you see how that vertex really helps me get this full graph. And I could kind of even change that. Maybe I want to go up to, let's say, 300. And if I don't like this, I can't really see my y-axis, so maybe we need to go down to like negative 50. Maybe that would show it up a little bit, or even negative 100. Okay, so that looks good. And there we have it. Okay, now on the graphing calculator, this is a little bit harder to do. Here, I'm going to make this a little bigger. Okay, so we are going to go into y equals and clear that out. Okay, and then we have our function 60x minus 0.5x squared. Okay, and the window, the vertex is really, really helpful. Okay, I know I need to go up to a maximum of 60 to see that vertex. So I'm gonna double it and add a little. So doubling 60 would be 120. Let's go up to 150, and then let's count by like tens, okay? And then I want to be able to see my axes, so I'm going to start at -10. Okay, now my y, again, I want to go up to 1800 because I found that vertex, so let's go up to about 2000. We can count by 50s or whatever you want to count by. Okay, but I like to be able to see my x and y axes, so I'm going to start it at -50. And let's see what that looks like. Pretty good. Okay, but unfortunately we can't just click on here. You actually have to calculate it. So you go second trace, that's how you get to that little blue calculate. And then number 4, or you can just go down to it if you want, or just hit 4. Okay, now you see the question is left bound, so we have to go over, so we're to the left of it and hit enter. Okay, and now it's asking us for another thing, right bound. So you go over to the other side, enter. And now you come over and guess about where you think it is and hit enter. Okay, and it's pretty close to that 60. We know it's 60 because of our algebra. Okay, and there's the 1800.